The 1st of February on Married Monday, you guys will be able to solve ratios and proportions, section 6.4. So a ratio, okay, I know it kind of looks like a patio, but the R just kind of sticks into the A there, okay? A ratio is a comparison. Comparazione? I have no idea. Yo no say. Of two or more quantities. So a ratio is just a way of comparing quantities, okay? Different numbers, different amounts, okay? So it can be done with two, or it can be done with more than two, okay? Weird flex, but okay. Yeah, Saren.
I'm so jealous, man.
Yeah, it looks like patio would be the word. Okay.
I never what?
I can't spell. Sorry.
Oh, I get what you're saying. Okay. So there's a couple different ways to represent a ratio, okay? Okay. So you can represent it like as a fraction, like A divided by B, like this number divided by this number. You can say the words A to B, TO2. Okay. Or you can have A colon B. And all of those are read as A to B. They are all read as A to B.
Wait, what's that second one?
It's funny how you're reading it.
It literally just says A, the word to, and then B.
Like
I thought that
T-O.
was A plus OB.
Yeah, sorry, no, it's just literally...
Oh.
How is your O not perfect?
Okay, there we go. Is that better?
Yeah, that.
What
No.
thing?
No.
Okay, A plus monkey tail T. Yeah, what's up?
May need to be farther
When
down.
you said that A, like the ways to represent has to be red, why can't they be blue?
Lizard is
Okay,
temporary.
so-
Monkey is forever.
Reject humanity, become monkey.
Okay, ratios can be simplified. We'll talk about that. So like a fraction could be, they can be simplified. So we're going to create a ratio here of saying, okay, a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. Write each ratio in simplest violins. So in simplest form, simplest violins. Oh my goodness. Okay. So we want to know the ratio of trumpets to violins. So we're going to compare trumpets to the violins. So we can write this in any of these methods. Okay. We can do it as a fraction. We can do it as the word TO, or we can do it as a colon. The most common one you're probably going to see is that third one, okay? The one with the colon. It's going to be the most common one because you aren't going to confuse it with a normal division problem typically. And it typically is more of a kind of way that we notate or write. Sarah, put it away. We kind of notate or write that it's going to be a ratio, okay? So if we're doing the trumpets to the violins, how many trumpets do they have? 40. So it's 40 to how many violins? 24, haha. So it's 40 to 24. Now, can we simplify that?
Yes.
Yeah. It goes down to 5 to 3. So that means for every 5 trumpets, how many violins are there? 3. So for every 5 trumpets, there are 3 violins. Now notice, when it said trumpet first, what number did we put first? The trumpets. When it said violin second, what number did we put second? Violins, okay? That was pretty important for us to do here, okay? So when we have flutes to clarinets, can somebody help me set this one up?
51 colon 39.
Okay, 51 to 39. There are 51 flutes for every 39 clarinets. Now, can this one be simplified?
Yes.
No.
By 3.
Not enough trouble.
Yeah, by 3 you can.
No, I think 30.
Okay, by 3 you can. Okay, 51 is not quite prime.
It's like 13 to 17 or 17.
Okay. I do believe it is 17 to 13. Yes.
And now that's
I'm always right. Wait, you can. What? Bill's always right. I don't
So
know.
for every 17 flutes, there are 13 clarinets.
That's one. Clarinet.
Okay. So I want you guys to try number 3 on your own. Yeah, Kelly.
What did you simplify to by again? Like, what did you simplify it by?
Oh, by 3.
Oh.
Yep.
Do we have to put the first one or can we just simplify it down?
If you can just do the simplified one already, go ahead.
Total done.
Bruh.
That'd be kind of like the equivalent of like not showing your work but still getting the right answer.
Yeah.
So if that makes sense.
I love that.
Number 4, do we count the violins with the total?
No.
Great question.
Yeah, it's
Well,
called
it says
total.
total. Otherwise, it would say all other.
So yeah.
Wait, you said do number 4?
No.
No, I said do number 3. People just jumped ahead. All right, on number 3, trombones to trumpets, okay? What are we getting for this one?
2 to 5.
Okay, we end up getting it as 2 to 5. Okay, well, how does this start out, okay? Well, trombone starts out at 16. Trumpet starts out at 40. We can simplify those both by 8, and it is 2 to 5. So for every 2 trombones, there are 5 trumpets. Now, what if this was trumpets to trombones? What would that be? 5 to 2. You just flip it, right? Okay. Questions on number 3 at all?
Oh man.
Not enough trombones.
Okay. We have some instrument elitism right now, okay? Now, on number 4, there's a great question earlier. I want to highlight that now, though, okay?
Highlighted.
So, Dominic said, hey, wait, on violins and total instruments, do we count the violins as part of that total instruments? And I would say, yes, we do. Because like Kelly said, she made a really good point of saying, well, if you didn't, it would probably say all other instruments. Okay, it would probably specify that. And I would agree. There's nothing here indicating that we don't include it. So we're going to include it in the total instruments. So there's 24 violins, haha. And how many total instruments are there if we add up all of those?
170.
There are 170. Very good.
We're too smart.
Okay.
I already did that, but you can do it.
Okay. I believe 2 goes into both is the only number that does.
Yep. So it's 85.
12 to 85. So for every 12 violins, there are 85 total instruments.
I was gonna divide them both like 12.
You get decimals / fractions.
Yeah, and then you can.
Yeah, I'm gonna have
this sum.
Yeah, we're gonna deal with whole numbers for our ratios.
I would say 5.
Guys, question on any of this?
No.
Okay, continuing on.
Next, we're in talking again.
Okay, so extended ratios. Extended means it's going to continue on. We're going to make it bigger, okay? So an extended ratio is going to be the specific one where instead of just having 2, we're going to have more than 2. So we said a ratio can be 2 or more numbers or quantities being compared. Extended ratio is specifically the comparison of more than that. So it's still a comparison.
That looks like paddocks.
Patios, yeah. Oh, you're saying like a C, okay. So comparison of 3 or more quantities. So it's just a specific type of ratio. So extended ratios are still ratios. It's saying specifically now there's going to be 3 or more, okay? So extended ratios, we're going to write these always as this, A colon B colon C colon. And once again, it's A to B to C. You could write it out as words, though, like A, T-O, B, T-O, C. Saren, backpack or on my desk. You pick one, okay? All right. We aren't going to do the fraction with this one, though, because then you get like a double-decker fraction, and that gets messy.
No, it's fine.
All right. But what if you're in the top, middle, and... Okay, I love that movie. Okay. Yes, yes. What?
We should have double-decker desks.
Yikes. Yeah, I see no way that ends poorly. Okay, let's look at number 5. The ratio...
That's 3 desks. No, Megadesk is 3 desks.
I think even Mission Plus is
Well, no, it's just... This doesn't actually do an extended ratio on this one, which is like why I'm confused. So 5 and 6 don't do extended ratios, but we use the information from 5 and 6 to get on to 7 and 8 to use extended ratios. So 5 and 6 don't use extended ratios, just so we're clear. But on 5, the ratio of 2 complementary angles is 3 to 7. Find the measures of both angles. Now, does that mean the measures of these angles are 3 degrees and 7 degrees?
It could be.
37.
Could they be 3 and 7?
No.
No, because then they wouldn't be complementary, because complementary means they add up to 90. Reminder, though, behind Aiden there we have the poster of complementary posters being nice to each other, okay? Aiden, you want to read that? What angle B says to angle A? Okay, will you read it now?
So it would be like 8.
Okay, I like the way, you're a good friend. I like the ways you always help me. Oh, they're complimenting each other. How sweet, okay? So, what?
I heard like
Okay. So angle B says to angle A, I like that you're a good friend. Angle A says to angle B, I like the way you always help me. They're complimenting each other because they're complementary angles. Get it? All right. It's a math fun. All right. There's no cheese there, no. Okay. So the ratio of two complementary angles is 3 to 7. So I heard somebody say 30 and 70. Okay. Well, does that work?
No.
No, that's 100. Okay. Well, how can we figure out besides just guessing and checking random things? Okay, Max. Okay, so Max is saying, okay, 3 plus 7 is going to equal 90. But mathematically, that doesn't work out. So I get what you're saying. We're going to have to divide. So 3x plus 7x will equal 90. Because we know they're both multiplied by the same thing. Because, like before, when we simplified, we had to simplify both parts by the same thing. So same idea. We're trying to figure out, well, what do we simplify by to get 3 and 7? So it's going to be our unknown variable, or an x, if we want. So 3x plus 7x is going to give us 10x equal to 90. Divide by 10, and x is 9. So now we know we multiplied or divided, we divided both numbers by 9. So can we find the original measures now?
Yeah.
By multiplying the 3 and the 7 by 9. The 9 that they were originally simplified down to. So what are the measures of these angles? 27 degrees and 63 degrees.
That's pretty cool.
I think it's pretty neat.
That's pretty neat.
Okay. Questions on that?
This is a math
Okay. The way it is. All right, on number 6, the ratio of two supplementary angles is 4 to 1. Find the measure of both angles. Raise your hand if you can help me set this one up. Okay? Let's go with Dominic this time.
4x plus x equals 180.
I agree with you. A ratio of 4 to 1, 4 for one angle for every one of the other, is going to make a supplementary angle. Supplementary angles add up to 180. So 4x plus 1x, or just x, we're going to figure out what did we simplify by. So we end up getting 5x is equal to 180. Divide both sides by 5. That's a really bad 5. There we go. X is
30.
No.
No. It's
46.
6. D. 9.
Yes.
7.
36.
I don't know. I'm not sure, actually.
It's
36.
I had one of the... I had 6.
I love the... it's this. I'm not sure, actually. Just like the realization, actually, I don't know. I realized I was talking too early. It's like I was hoping to find it by the time I started talking, but I didn't, so this is where I'm at. I get it. It's a real thing. Okay. So we go back and we plug this in, and what are the measures of both angles?
144 and 36.
144 degrees, and we have 36 degrees. Okay, and however you want to list those is okay. If you don't want to do this little and that I do, if you want to do an actual and symbol that I just can't draw, I'll be honest. Okay, or you want to write and, or you want to do a comma, or you want to write like the measure of this is this, measure of this is this, you can. Yeah, Kaya. I don't know.
Try it.
Well, okay, so just so we're clear, when I screenshot on this, though, it still has a screen recording, and so it doesn't pull up the screenshot on yours. I have to remember what an and symbol is, though.
Yeah, I don't know.
Yeah, no. Everyone's here.
Yeah, everybody's here.
It's an 8.
Okay.
It's an 8 with like a tail.
Why do you want it like that? This must be even.
Look on his keyboard.
What?
On Liam's well, it's an A.
Do two circles with a line coming out of one of them. That is the correct.
It's
No,
an 8 with
it's
a
an A with a
it's
something
an
on
8
top.
with a deflated bottom.
Nope, it didn't work. I wrote an and symbol, though.
Yeah.
Good job.
She wasn't totally disgusted by it, so that's something.
You learned
That's
something
an 8.
Yeah, it
Very
wasn't bad.
deflated 8.
You learned something new. You may now retire.
Bye-bye.
Okay, anyway,
I'll see you later. Wait, he's leaving us?
continuing on.
Wow.
Oh my
Yeah.
god.
You know we're learning the ratios. I think we actually were learning.
Yeah, I think we were.
Okay, everyone always says we were learning slope when we left. We were learning this when we left. What was it? Okay,
Well, there was
Two
like-
teachers left us.
that's fair. That's fair.
Okay, no, we were learning slope when Mr. Wallace left, and then we were learning algebraic equations when Ms. Brown.
Okay, so on number 7, the ratio of the measures of angles of a triangle is 4 to 7 to 9. Now we're seeing a standard ratio. Find the measures of the angles. Does anyone have an idea of what we could do on number 7?
Well, I have
Go, Gage.
4x plus 7x plus 9x equals 180 degrees.
I like the extra commentary voice in that. Okay, like the announcer, like it's almost like Mortal Kombat, like 4x plus it. Okay, so 4x plus 7, or like a slam ad. You know, like
Yes.
this person will go to the store and do this. You know, like blah, 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 blah. But our candidate does this. But this person, okay, anyway. So 4x plus 7x plus 9x equals 180. All three angles of a triangle up to 180. Now, we don't know what the angles are. We know the angles aren't 4, 7, and 9, but they're 4 times something, 7 times the same something, and 9 times the same something. Question on how we get this. Okay? So, yes, Kaya.
All the x's together, which is 20x equals 180, and then divide 20 by 180. And
So
then
90.
x equals 9. And then plug it in to all the other three numbers,
Yep.
the x's, and you get your angle.
And we get 36 degrees. We get 63 degrees, yep. And 81 degrees.
And 82 degrees.
And that's our answers. Assuming those are the answers.
That's our answer.
That's our answers. Awkward.
Sounds like a TV show.
Alrighty. Any question on number 7?
Why?
Okay. On number 8. Okay. Ratios of the angles on a triangle are 11 to 2 to 5. Find the measure of the largest angle. Anna, can you help me set this one up?
11x plus 2x plus 5x.
Nailed it. 11x plus 2x plus 5x equals 180, okay?
Is it always 180? Yes,
Because it's a triangle. Yep. So it's all about what we're adding up to. But when we add it to a complementary angle, it was to 90. Supplementary, 180. To a triangle, 180. Okay? So 11x plus 2x plus 5x equals 180. Add up these, and we get 18x equals 180. So what's x?
10.
10. It's a nice, easier one to divide. Okay? So that makes the measure of our angles 110 degrees. Do we need to find the 20 and 50 this time? No. Could we know it to check our work?
Yes.
Sure. Check it by making sure they add to 180. Oh, they do. Okay. All right. The ratio of the measures of the sides of a triangle is 2 to 8 to 10, or excuse me, 2 to 8 to 9. If the perimeter of the triangle is 76 inches, find the length of each side. Okay. Wait. What's perimeter mean?
The outside.
Okay, the distance around the figure. How do you get perimeter mathematically speaking? You add all the side lengths, right? So, these are the side lengths, right? Or the ratios of the side lengths, okay? Does anyone have an idea on the problem we could do here that might help us out? Okay, Aiden.
10x plus 9x equals 76.
Okay, I'm going to back up a half step before that and do 2x plus 8x plus 9x is equal to 76, okay? Saying, hey, once again, these are all simplified because 2 plus 8 plus 9 is not equal to 76. But 2 times something, 8 times the same something, and 9 times the same something will give us 76 a total perimeter. Now, Aiden went ahead and said 10x, which is 2 plus 8 already. So it's really 19x is equal to 76. Aiden, you look confused.
4.
Okay, x is in fact 4. Yep, as Dominic and Gage were saying. Okay, now we want to know the length of each side. Okay, so what is the length of each side here?
8, 16, and 18?
Okay, 8,
No.
not 16,
32 and 36.
32, and 36. Now what's the label for each of these? Inches.
Wait, labels? What?
Well, is it 8 toddlers long,
Yes.
32
Yeah,
toddlers
yes.
long,
8
and 36 toddlers long? I don't think so. Because a toddlers could be a variable measurement because a toddler could be a different length depending on the age or depending on the toddler.
Orphans.
Okay, we're not going to measure things in toddlers.
I figured out
Okay,
how to do
it's
so.
also probably immoral.
Orphans.
Okay,
There's like 50 kindergartners, and now I know why.
what?
You took them all.
Like the normal class size is 100,
Yeah.
and now there's only 50.
You
So
took
somebody did something with the toddlers.
You took them.
He took them all, and then he used them as measurements.
And now you're gonna
You weren't
leave.
supposed to find that out.
Okay, Kelly.
The reason I pointed it out is because I got so many points off last year for not doing labels, and I just had to. I had to I had to.
For me?
Ruin our lives.
Yeah.
Oh.
So many points off.
Yeah, I do that. Yeah, I do that. I'm a jerk about it.
I thought I was doing labels, and I was just like, oh, they're not important. And I'm like, oh.
They're not important.
Yeah.
That's not important.
You learned something.
No.
Yeah, we didn't learn anything.
That's how I know I did a good job right there. Kelly learned that labels are important. If you learned one thing, I'll take it. Okay. So
Learn one thing before you leave.
no. Okay. Anyway.
He's gonna leave us like all the others.
All right, guys. Give me a quick thumbs up if you're feeling good about these. Thumbs down if you're not. Okay. And I want to see everyone vote. Okay. Thumbs up if you're feeling good. You can keep it more secretive if you want. Okay. Does anyone want to do number 10?
Yes.
Aiden.
homework.
Okay, we're skipping it anyway. Okay, let's look at number 15.
Hey guys, that's the next warm-up.
Wait a second, what?
There we go.
Oh, there we go.
What's the proportion?
Makes more sense. I skipped 2. Okay, what is a proportion? So a proportion is going to be an equation.
Why are the letters pushed together?
I don't know. That states two ratios are equal. So a proportion takes two different ratios and says they're equal to each other. This to this is equal to this to this. Now, a lot of times, we're going to see these ratios as fractions, okay? So a proportion is written as A to B is equal to C to D. Now, for these, in order to solve, we're going to cross multiply, okay? Have you guys done these before?
Yeah.
Okay. Hopefully they're decently familiar. You do A times D is equal to B times C. What you end up doing is you end up crossing. A and D are diagonal from each other. They multiply. B and C are diagonal from each other. They multiply. The math that supports this real quick, okay, you don't have to write this down if you don't want to, yeah, basically. So if we're dividing by B, okay, on the left side, then we would need to multiply by B over 1. And now if we're doing it on this side, we need to do it on this side, B over 1. Okay, so we're going to have A is now equal to BC over D, because it doesn't matter whether we write B or C first, but I'm going to put them alphabetical. Now at this point, we want to get the D on the numerator as well, so we're going to multiply by D over 1 to reduce those, but now we need to do it over here. And so we end up having A times D is equal to B times C. So that's the math that supports it. But cross multiply, you jump right there. Okay, this is the math that supports. What was that?
This is what I do whenever I try to find percentage.
Okay.
Yeah, like when you do like
Oh yeah. Yeah. So you're doing you're doing a proportion. You're doing a proportion. Yep. So you're trying to find how much of this number, 2/8 of this. Okay, you're doing really a proportion. Yep. Yeah, Max.
So, like on 11, we be multiplying 7 instead of dividing it by 2?
Okay, so great question. So on a problem like number 11, what ends up happening mathematically, since we're trying to find this x, okay, is we're going to have to multiply both sides by x, right? Don't write this in. Okay? You're going to multiply both sides by x. Those reduce. So right now we have 4 is equal to 2x over 7. Okay, well now we need to multiply by 7.
So 28.
So we get 28 is equal to 2x.
14.
And then we divide by 2, right? Now, this is the same thing as what happens if we were just to say cross multiply. 4 times 7 is 28. 2 times x is 2x.
Well, that's a lot easier.
So mathematically, you can just get there quicker. Because you know what I'm going to have to do is multiply by the reciprocal here, multiply by the reciprocal here. Let's just shortcut it. Let's just go there. We know that's what's going to happen. Okay? Aiden.
I have 2 questions. Okay, so how do you, what's the next time go?
All right, we're going to get there later. Okay?
Look at my go. Okay. How do you let's see here.
Okay, we're going to get there later as well. Okay? So right now, though, on the problem we are on 11, 28 is equal to 2x. You divide both sides by 2. And x is 14. So what we're saying is this proportion would be 4 to 14 is equal to 2 to 7. Is that true that 4 to 14 is equal to 2 to 7?
Yeah.
Now, someone might look at this and say, and notice, 4 to 2, well, 4 is double 2, right? Or 2 is half of 4. So what's this number have to be to make sense with 7? 14. So sometimes you can figure them out that way as well. It's kind of like, what's the missing piece? Okay? And if that's the way you want to figure it out, you can. Okay? Sometimes that involves a lot more guessing and checking, though, than just the actual algebra to get it there. Okay? But it is technically a way that can be done. Sometimes it's quicker if you get it right away. But if you're guessing a lot, then it's not going to be quicker. It's like ACT style, okay? If you're doing a problem like this, guess and check can be quick only if you get it right, though. Okay? If you're not getting it right away, you're wasting more time than if you just do the problem. Does that make sense or no?
Sure.
All right. So, yes. So on number 12, what would we have to do mathematically?
19 times 12.
Okay. You have to do 19 times 12.
228.
Okay.
I like the best
is equal to 10x. So now what do we do?
Divide.
Divided by 10. So 22.8 is equal to x. So on this one, would it have been easy to guess and check that 22.8 was going to fit there? Not really. Okay. Now, let me show you why mathematically sometimes it's also not quickest just to cross multiply, okay? I probably wouldn't teach this if you guys weren't the honors class, but you are, so I want to show you guys this, okay? That it actually can be quicker when the variable you're trying to solve for is in the numerator, if you just multiply by the 12, okay? Because what would happen is you're just saying, okay, if we don't do the second part of it, if we just do the blue that I'm doing now, the 19 times 12, and we just do 228 over 10 is equal to x. Does that kind of take out that last step of saying that we need to divide both sides by 10? Yeah. So the downside to cross multiplying, okay, is that sometimes you actually create an extra step when the variable's on top. When the variable's on the bottom, you end up saving a lot of steps because you're shortcutting through them. But when the variable's on the top, you end up actually doing an extra step. So typically, personally, when I look at this, I analyze it for a second. I say, okay, well, where's my variable at? That's going to determine what I want to do. Do I want to cross multiply and then divide? Or do I just want to multiply and divide? Does that make sense or no? Okay. And if that doesn't make sense to you, if you're just like, Ms. Gossel, I'm struggling with that second one of knowing why this would be helpful to just multiply one side and not cross multiply, just cross multiply every time like it did in the purple, and it can work just fine. Okay. Saren?
Numerator's the top part, right?
Correct. Yep. Okay. Yep. Good clarification. Yep. Numerator's the top part. Now on 13, x minus 1 over 6 is equal to 13 over 19. So this one, yeah, Kyle.
I did 19 parentheses x minus 1 parentheses equals 6 times 13.
Okay, 19 parentheses x minus 1 is equal to 13 times 6, which you said was what?
I just said 6 times 13.
Oh, you just said 6 times 13, yep.
But that's 6 times 13 is 78. And then
Very good.
review the
Yeah, so before you get there, I totally agree with this. So Kaya said, okay, when we cross multiply here, we do 19 times all of the numerator x minus 1. We don't just do 19 times x or 19 times the negative 1. We do 19 times the whole thing. So you have to distribute it. So we put it outside the parentheses to know that, hey, we're going to distribute this, okay? So it's going to be 19x minus 19 is equal to 78. Any question on that or no?
Yes.
Okay?
What?
Okay, so what happened mathematically here is as we cross multiplied, okay, we multiplied by a 19 over 1. Now as we multiply by that 19 over 1, this 19 has to distribute into the fraction there. And so what we're doing is we're saying, okay, we need to distribute into it. Because we can't just multiply it to one thing and act like it's going to be the same thing. You need to multiply the entire side. Does that make more sense?
Yes.
Awesome. Anyone else have any questions on how we got there, why we did that kind of stuff? I want this to make sense to you guys.
Hey, should you do it?
Okay.
Why?
Okay. Why do I want it to make sense to you?
Yeah, why?
I want it to make sense to you because once it makes sense to you, it's going to be a lot more tangible to you, and then you're going to have a much better understanding and remembrance. So, 19x minus 19 is equal to 78. We're going to add 19 to both sides. 19x is equal to 97. Divided by 19. It's something. That's true. It is, in fact, something, okay? It ends up being
like 5.
5.1.
How, for something like this, how,
Use a calculator.
no, like, where do you want us to round to?
Oh, on this one, I don't think you have to.
No.
Go do math.
In the future.
If you have to round, I'll tell you where to round to. How about that?
Because this one rounded to, like, 5.105.
Oh, this one didn't round? This one didn't end?
Well, it's 5.0.
Ah, okay.
I rounded
Let's go to 10th unless I state otherwise. Okay? There you go. All right, question on 13?
Okay. 100.
Yes, yeah. Because it takes 10 of these to make a whole. It takes 100 of these to make a whole. So it's a 10th of it.
So much more sense.
Yep.
Wait, I don't do it.
Yeah. Yeah, it's a real thing. Yeah. Yeah. That's why it's called a tenth, because it's 1/10, 2 tenths, 3 tenths. When you get to 10 tenths, you have one whole. Okay.
The way I was taught was
Yeah.
that dot was like the 1, and you just kept on adding.
Yeah, you can think of it that way too. But the actual mathematical reason is what I was just saying, though. Yeah. Max, what's up?
Then the answer would be 4.1 over 6 to 13, 19.
Sorry, what, buddy?
Then
Oh, you're saying what would actually go on the top of this fraction would be 4.1? Yeah, so if you're trying to figure out what goes on top of this fraction, then sure. Here we're just trying to figure out the variable, though. But yeah, if you wanted to plug it back in, it'd be 4.1. So you could double check and say, 4.1 divided by 6 is that equal 13 divided by 19, excuse me. And you should get the same thing. Yeah. All right, on to 14. Can anybody tell me what I would do on 14? Kelly. That was music to my ears, Kelly, because you said it the exact way I would say it. 5 times the quantity of x plus 4. Ooh, I love that, okay? Is equal to 323, okay? Love that, love that. Love the quantity of. Ooh, gives me shivers down my spine in the best way, okay? So, 5 times the quantity of x plus 4. Now, if you guys want to, okay, in your head, do the distributing of 5 to the quantity of x plus 4, feel free to do that. And just go and skip this line and just say, that's 5x plus 20 is equal to 323. If you're able to do that in your head and you want to do that in your head, feel free. That's okay with me, okay? Does that make sense? Okay? I'm not a fan of just writing math just to write math once you actually get it, okay? Now, students that don't get it, honestly, I'm going to encourage them to continue to write it because that's how you end up learning it later, is by writing it all the time, and you notice these patterns and you're like, this always works out this way. I can start doing this in my head now. Great, do it in your head now. I won't write it out if you want to be more careful. Either way. Does that make sense? Okay. So subtract 20. 5x equals 303. X is equal to, I got 60.6. Oh, as I'm behind the thing. Okay. X is 60.6. Okay. Questions on that? So can I just be clear, when I said the 10th thing earlier, though, it's 10th unless it actually does terminate, like after like 2 or 3 or 4, then we'll just terminate it.
What is 15?
Okay? Yeah, let's go to 15. 10 over 2x minus 9 is equal to 20 over 9. So this time, we have to cross multiply again. So we're going to have 10 times 9 is 90. And we're going to have 20 times the quantity of 2x minus 9. So we're going to have 40x minus 180. So if you want to shortcut the distributing, like I just did here, that's how you would do it. If you want to write it out and then get to the step, feel free to write it out and then get to this step. Does that make sense or no?
What? I get it, but like, why? Not like their why, but like.
Yeah. Like what do you mean by why?
But why? Why
Like,
would we have
when will we use this in life?
Yeah, great question. So different ratios and proportions, they can be just used for comparing numbers. So there's a lot of different aspects where you'll compare numbers, like different business aspects or sales or
Driving a truck?
potentially. Yeah, you could figure out sometimes there might be a way or a time you have to figure out mileage, something like that. Yeah, your mileage with it and comparing mileage of 2 different vehicles, or if you put on this thing on your semi versus this thing on your semi, this part that might affect the mileage, or this kind of weather versus this kind of weather. It could. Yeah.
But would we really have to go this in depth?
So here's the thing, okay? We're setting you up for this, so this way, if you end up using it, great, you're ready. If not, it's still problem-solving skills that are just very helpful to be able to sit here, analyze, think about, how would I solve this problem? Oh, here's how I solve this problem. And it can help you solve problems in the future as well. Like other problems, not even math-related, because this is developing critical thinking, which is helpful in all facets of life. So at the very least, even if you're not going to use this specific math, okay, which you might not, okay, to be fair, okay, it can still be useful in other ways. Does that make sense at all? Okay. Aiden.
And you can use it to help your kids on their homework.
Yes, of course.
Yeah, I'll remember that part.
Yeah.
I'm thinking ahead here, but would it be like 12 divided by 8 over 18 equals 3x
That is what it is.
X minus 20 over 3 equals X minus 11 over 18. Could just keep on going on and on.
I'm not sure what you're doing there. Maybe we can talk about this later, okay? Liam.
Because the 10 is going from 10 to 20, it's going to go from 4.5 to 9.
I like that. So Liam's doing that kind of the guess and check thing we were reasoning earlier, saying, hey, 10 went to 20, so it doubled. This went to 9, so it should double as well if it's going to stay consistent, which it has to. Saren, put it on my desk right now. Thank you. Okay, so this bottom part should end up equaling 4.5, so we could do 2x minus 9 equals 4.5 as well, and then solve for x, okay? But you have to remember that x won't be 4.5. The whole denominator is 4.5. That's the common trap that people fall into when they guess and check, and it's not just the whole denominator.
It's not 0.
Okay? Probably not.
Yeah, because...
So anyway, let's continue on and we'll find it.
Oh, wait, no, I'm not.
80 or 100? Liam,
So we're going to add 180. We're going to get 270 is equal to 40x. Divide both sides by 40. Okay? And x is 6.75, yep.
nice.
So close.
6.75 or 60?
6.75.
What about 6.76?
No.
Oh.
Okay. Aiden.
Did you pay it coin a quarter because it's 25 cents?
It's the funniest one.
Yeah, what was
All right. We're going to skip number 16.
Wait, hold on. And then you
Did we
just
do number 9?
then you would just plug in 6.5 to x.
If you wanted to, you could plug in, to check your work, if you wanted to, you could plug in 6.75 to x. And it should work out to be 4.5, which it does.
Your elbow's kind of slack in there.
Someone calculate.
My elbow?
No,
Bless you and bless your hands. I don't know if I was
your
forget.
elbow.
Oh, it is. Okay, did that answer your question, Gage?
Yeah.
Okay, you don't have to, though. This is your answer, though.
Yeah.
Okay, Aiden.
Can we do 17, 18, 19, and 20 so I don't have a seizure when I go?
We'll do 17. I don't think we need to do 18 once we do 17, but we'll do 17.
What about 19?
So, and we'll do 19, okay?
What?
19 is weird.
Yep.
It is? It is.
Okay, so on 17, we notice we have a couple different x's, right? Don't let that freak us out, guys. We're going to do the same math we've been doing.
Scared.
It's going to be 18 times the quantity of x minus 20. And then it's going to be 3 times the quantity of x minus 11. So we're still doing the same cross multiplying we've been doing. Okay, that part's consistent. Now, as we distribute this 18, we're going to have 18x minus 360 is equal to 3x minus 33. They are pretty small. Yeah, they are pretty small. That would not help. Okay. So from here, okay, let's subtract 3x. This just turns into a regular algebra equation. 15x minus 360 is equal to negative 33. Yep, calculators are okay. Add 360. Saren, good thing I have calculators up here.
I was using a calculator on my phone.
Okay, well, you were on your phone a lot today, and I warned you, and so I just saw you typing when we were talking, so.
Actually, my mom.
I actually did take my mom in class the other day. I took my mom in Howard's class the other day.
What do we get x to be?
A lot.
Take your phone out and Howard's class.
327 divided by 50.
21.8.
We were supposed to be using it as a calculator.
Okay. Does that make a little more sense on how we would do 18? It'd be the same exact thing, except for there right now it's in the denominator, but we would still do 6 times the quantity of 3x plus 3, 7 times the quantity of x plus 16, solve it the same way. Questions on 17, 18?
When can we do
Why?
19?
Okay, on 19. Now, we notice, are the variables both in the denominator or both in the numerator this time? No, they're actually going to multiply with each other. So we have 5 times 27, which is going to be
Does that mean x is
135, yep.
squared? Does that mean x is going to be squared?
It is going to get a square. So we're going to have x minus 1 times x plus 5. We're going to have to, what we do, we call it FOIL. FOIL is kind of our slang for it.
We
Okay?
did that last year.
Good, good.
Before she left us.
So, guys, here's what FOIL stands for.
Wait.
Okay?
Are you
FOIL stands for, first, outsides, insides,
I'm an officer.
and last. Yes. I like this one part. Yeah, I like this stuff a lot. So you get 135 is equal to the first, x times x, the first in each parenthesis. X times x is x squared. The outside's x is on the outside, 5's on the outside, plus 5x. The inside's negative 1 times x, negative x. Negative 1 times 5, the last in each parenthesis, negative 5. Gauge.
Okay. Sort of off topic.
Yes.
I don't ever get it. Did you guys know that meta stands for most effective tactics available?
I think it can be, but I don't think it has actually what it means.
Meta?
Meta. Like, you know,
I feel like
like,
someone just made that up, but meta was just a word.
I feel like, no, meta usually means it's about the thing. So like a meta discussion would be a discussion about discussion.
no, like in a video game, like that's the meta.
The new meta?
Yeah, the new meta.
Meta Knight.
No.
There's like different genres of meta.
Maybe. I feel like it's more meta, but we can look into it.
It's pretty cool.
I enjoy looking into that. So 135 is equal to x squared plus 4x minus 5.
That hurts.
So what we're going to have to do to solve this quadratic equation, okay, this quadratic equation, okay, chapter 8 in Algebra 1, if you're curious, okay, quadratics, okay,
She loved us in algebra.
okay, is also the tail end of chapter 7, factoring, okay, because we're going to have to factor. We get a factor. I love factoring. Factoring is the best, okay? So, what we have to do to factor, though, first is you do have to subtract the 135 from both sides. We have to get it equal to 0 for this to work. So 0 is going to be equal to x squared plus 4x minus 140. We have to have it equal to 0 for this to work out. Now, to factor, what we need is we're going to want to create two factors, aka two things multiplying together, okay, that are going to equal 0. Because when two things multiply to equal 0, what do we know about at least one of those things?
They gotta be
It has to be 0. Otherwise, it won't equal 0. So we're going to say, once we have multiplication that equals 0, right now we have addition and subtraction. Once we have multiplication that equals 0, we can set them equal to 0 and say, okay, well, if either of these are 0, this equation is true. Okay? Saren?
When you set the x squared, you zero that?
No. So what we have to do is we have to create multiplication first. So it doesn't work with addition, because you can add all sorts of things to get to 0. Okay? It works with multiplication because when they're multiplying to get to 0, one of them at least has to be 0. So we do what we call factoring to create these two parentheses. So we're going to have something in a parenthesis here, something in a parenthesis here, multiplying. It's called factoring because factors are two things that multiply together, two or more. Okay? Thank you, Kelly. Okay? Now, I teach a method called the X method, okay, in order to factor, okay? Levi and Kelly had me last year, so they're going to be very familiar with the X method, or at least a little more familiar, okay? Kelly's going to be very familiar with it because she's been doing it in Algebra 2 as well, okay? So Kelly, you're probably real hot to trot on factoring right now, okay? So for the X method, I do the A times the C on the top and the B on the bottom, okay? This is just a little tool we use to help us, okay? A times the C, this is in the form of ax squared plus bx plus c. It's called a quadratic equation, okay? An equation with x being squared. The a's in front of the x, it's currently 1. The c's in front of the c's at the end is negative 140. 1 times negative 140 is negative 140. I encourage you guys to write this part down with the x if you're not already.
I do not understand.
Photo map.
On the bottom, we're going to write whatever the b is. The b is whatever's with the normal x. That's 4. Now it becomes like a puzzle. Straight up, this is a puzzle. Okay? So, there you go. So we need two numbers that are going to multiply to the number on top and add up to 4. Now, here's the thing. If they're going to multiply to a negative number, we know one of them is going to be negative and one's going to be positive, right? So, we need two factors of 140 that add up to 4. In this case, have a difference of 4 because they're subtracting. So, there are two factors, two numbers that multiply to 140, but add, or in this case, subtract to 4. What do we think those are going to be?
7 and negative 2. That don't work.
Okay, well, 7 and 2 are going to be 14, not 140. So, maybe 7 and 20. Okay, but those are 13 apart, so we needed something bigger. Well, what else could go? What's bigger than 7 that goes into 140?
80 and 60. 80 and 6.
14 and 10 multiply up to this. Now, which one's going to be negative, Kelly? 10. Because negative 10 plus 14 gets 4. Negative 10 times 14 gives us negative 140. Now, we actually can do a shortcut here, which is super duper handy. Because
Now you tell
we
us
have
that.
a 1 in front of this. No, this part is a shortcut. That part's the part you have to do. This part's a shortcut, which is really nice. Because there's a 1 in front of the x squared, we can actually just put x minus 10 from this side over here. And x plus 14 from the right side over here. It turned into this. If we were to FOIL this back out, like we did up here in the purple, you would get what we started with. If you were to FOIL it, you'd get what we started with.
So is that our answer?
Not quite. So, yes, Aaron. It's I don't think it is, but we can. Yeah. Anyway. So this x minus 10 is multiplying together with x plus 14. These two things are multiplying together to equal 0. So we know at least one of them has to be 0. So we say, okay, at least one of those has to be 0. So let's say x minus 10 is 0 would make this work. So if we add 10, if x is 10, and we plug that back in, what do we get 0 for this parenthesis?
Yes.
Yeah, and does this equation then true?
Yes.
But wait, there's another option here.
What? Negative.
If x plus 14 is equal to 0, then this part is 0, and then it's also true. So you subtract the 14. And so if x is negative 14, and plug that back in to both parentheses, this one ends up being 0, and so it ends up being true as well. So this one has 2 answers. A hint, whatever your highest power is, should be the number of answers you get. 2, because it's squared. Yep, the highest exponent, the biggest exponent, the highest power, degree, exponent, whatever word you want to use for that. Okay, here's what I'm going to do. Okay, I'm going to assign the homework like normal because I'm a jerk. Okay, there's I think 1 or 2 of these on there. Okay, the homework that you have to factor. Okay, the rest of it are the other ones we did / the ratios we did earlier. Okay, and then I'm going to put on the Google Classroom. Okay, if you want, I'm going to put my Algebra 1 videos of how to factor on there as well if you want to go back and use that as a resource. Okay, if you also want to come in and ask me about it, feel free to do that. Yes, Aaron.
So do we put x equals 10 or 14?
Technically, yeah, x could be either.
Or do we just put both?
You just put both like that.
Okay.